Um, it's kind of like our final design, which you're gonna see later on. But basically, it was just a piece that held the pitot tube in place. And here, as you can see, the pros, it did hold the pitot tube in place like what we wanted to. It plugged into the existing hole into the plexiglass, and then it also allowed for the depth adjustment. But one of the cons was as you turn the wind tunnel on and increase the speed, it started to lean forward. So then that would make the results not as accurate. So then we had to go back to the drawing board. And then next, this was take two on the design. So then we came up with another piece that would hold that original design in place. But another pro was it prevented the rig from leaning forward like the last one had a con about. But this con was it failed to take the static pressure tap because as you can see, the pitot tube, we weren't able to adjust it at a different height.
Yep.
So then we had to go back to the drawing board again.
So you can see here, this static pressure tap points out in front, and we did not take that into account here. So once you reach a certain depth, it would just hit that support, and we couldn't move further down.
Yeah. So then take three. This is our third design. It's the same as the original two, but now there was a slot created that allowed for free vertical movement of the pitot tube so we could adjust the height. However, the con of this one was it started shaking at the higher fan speeds, especially like when you reach greater depths. So we needed to come up with something that would also stop that because then that will cause discrepancies in the data as well. And then lastly, our final design. It's the same as all the previous designs, but